Welcome to Subject to Change. Lauren and I are talking with Lisa Goodwin Robbins about specifying embodied carbon in healthy materials.
Hello, it has been forever and a day.
I know. And I hear you have a new job.
I do.
That's very
I'm very
exciting.
excited.
NESEA, the Northeast Sustainable Energy Association.
Did you go to NESEA?
I did. It was exceptional because, and maybe it was, I don't think it was just the sessions I attended, but the two most prevalent conversations were about kind of like the emotional intelligence in staffing, including diversity and dealing with remote access and really being a whole company that supports your staff. That was like, there were like half a dozen sessions on that.
That's really unusual.
Really cool. And a lot of them were interactive sessions that forced people to go through a thought process. And then another big chunk of the sasessions were about embodied carbon. And there are all these fantastic tools out there now. There's a new one that Sasaki just is releasing in beta. And it's a planning level tool. It's called Carbon Conscious.
Okay.
And it's on their website. And it's it's this really cool tool because what they've done is they've created the ability to like put a plan out there and create colored pens that relate to different libraries of embodied carbon. Like you could they have it set up a dozen different wall sections, for example, and several different pavement options and several different approaches to landscaping. And if you use the colored pens to draw on the map, you can quickly sketch out the square footage of these different carbon burdens, and it instantly creates a graphic mapping of the relative level of carbon burden with the same colors, so you can look back and forth at your planning document and really get a sense of the impact of your building, the impact of your landscape, and play with it.
That sounds really cool. And
in the moment.
Sasaki's a good team to do that because they think about master planning and landscaping and all that stuff in-house.
Yeah. So cool. I'm hoping that, it's in it was like a baseline introduction. It was an hour and a half session. It was incredibly well attended. I think that hopefully the future of that tool will be the ability to like take your own office standards for wall types and for pavement applications and load that data in. Right now, it's not editable for your own stuff. You can only use the metrics that are there, but the metrics are, there's enough representation for you to start to have that carbon literacy about what costs a lot of carbon and what doesn't.
That's cool.
Please don't forget to like, comment, and subscribe. When you see the little microphone in the lower right, click on that to learn more. We're so glad you're here.
You have Kaylin Associates up on your title.
Yep, that's where I work. I didn't even think about that.
Anything go down there?
Well, we just write specifications. There's 8 of us writing specifications. So we see a lot of projects. Most of our clients are in the New England area, but the work is all over the world. And it's an interesting cross section, an interesting way to see what's going on.
It's about speaking the same language.
Talking about specifications, and language specifically, I guess, as we're talking about offices, right? So there's new language, right? Or language we should all be utilizing for tracking embodied carbon, right? And developing other things. So can you talk to us a little bit about that?
Yes. And I'm super excited about it because it's been like, I've been on the edge of my seat thinking it was about to come out. So Stacey Smedley rounded up 3 really smart women specifiers, Ann Hicks-Harney, Lana Rarick, and Beth Shroshane. And they cranked out some language, and then they shared it with a few people, and they said, Stacey's going to release this, so don't tell anyone about it. And that's been making me crazy. But the great thing about it is it's very brief, it's very digestible. And it'll just get us all thinking about the same thing in the same way. Do you remember when we started asking for VOC content? Yeah. And people didn't understand what we were talking about, and we got all these weird measurements. So we finally got to grams per liter, and this language from CLF or Building Transparency or whoever it is will get us all talking about the same language. It points out that you have to have the same PCR to be able to compare embodied carbon units. PCR is product category rules.
Right.
And you have to have an agreed
I knew
upon
it was something rules,
category rule. Yeah.
Right.
The industry group kind of has to agree on what the product category rule is before you can do an LCA of your individual product. So that means you can't have an EPD if you don't have a product category rule.
So, and spell out those acronyms as well, because we hope that our viewers are a mix of people associated with the industry and not. So
LCA is life cycle analysis, right?
And then an EPD, we've mentioned before on the show.
An environmental product declaration. Right. And that comes, so you need to go from having a PCR to doing an LCA to having an EPD. And if you're missing a PCR, you just can't do anything.
Right. Right, because you could be measuring entirely different things than the comparative product that you're playing off of.
Because the great promise is that we can do apples to apples comparisons, right? Mm-hmm. And someday we'll get there.
Carbon dioxide equivalent, or CO2e.
Well, it's like the whole discussion of CO2e. I mean, that at least started people talking with operational carbon in particular, started everyone realizing that we could understand all of the potential greenhouse gases related to one metric and at least get to kind of order of magnitude comprehension. I don't know if that's changing operationally, but that's where it's been for a little while anyway.
I don't really know about that.
Yeah.
I don't know that much about the operational part.
Yeah. So no, that's cool, because I
don't know that much about the embodied carbon part. Like, it's new for all of us.
Yeah.
Give good directions.
Yeah. The high point is that it's brief, easy to understand, and easy to share.
That's awesome.
That's the really important part.
When you change the world, you have to actually give people directions.
Yeah. Easy directions.
Easy directions.
Easy directions.
All right. So they gave us some Division 1 definitions.
Ooh,
okay.
Which is important, right? So if in Division 1 of your specifications, if you have a sustainable design requirements section, you could add this language in. Whether you were following a certification program or if you just have a generic one, and it defines the cradle to gate part, A1 to A3, which is what we're working on right now.
Right. That's misunderstood in a lot of by a lot of people and even I struggled with it in writing a lower carbon concrete spec for New York State. It's just the manufacturing part, the production part is definitely in the mix, but then dealing with transportation, and that's a whole different animal in my head.
Really surprising results in the transportation thing. Like, that I have a neighbor. My neighbor is Dr. Tom Gloria, and he's the guy who signs a bunch of the EPDs at the bottom for UL.
Can we interview him?
Oh, cool.
Wow.
Like really, really funny. But so he does analysis for companies, and not always building product companies, but other companies. And sometimes they're shipping products around the world, doing one thing here and one thing there, and they think that their big problem is the shipping, the transportation, but it's not. It's actually like one of their procedures in one of their countries is a problem, and the other stuff doesn't really matter as much. So
isn't it amazing?
That's the great thing about the life cycle analysis, is that if you do study the whole life cycle of a thing, then you find things you didn't know about your products. And that should be what everybody wants to know, because then you can make more money.
If you stop throwing things away, you can use them. Who knew?
But you can't have toxic things to start with.
Oh, I know. It's crazy.
Right? Because you can't then recycle them back in.
The rules for the game.
If I have a project that's about to go out, so like it's 100%, but like, how there's always a back check and everything that occurs with government work. is it too, can I put it in now? I mean,
You
it's not out to
can,
bid,
but
technically.
be careful what you wish for. You know, what if you find out you've done a really crappy job already?
Yeah.
You know,
okay.
what if you start asking for this information and you find out that you've actually done a terrible job with embodied carbon? I think that the people who
No, you're
should be
right.
ready to slip it into their specs are people who've been trying really hard with their design decisions about embodied carbon. And now we could get this language into the spec and they could actually track the numbers.
So I'm gonna take a beat on it this project, but my next project I'll do.
That's really admirable. That, I mean, and a great point. It's Division 1 is the place where you can have the umbrella statements and the
Right.
reporting requirements for the stuff that's already baked into the technical specs. It's interesting. I've been working on that spec for New York State, and I was working with a bunch of people who are not part of the building industry. They're all, you know, policy people, and awesome, amazing policy people, and facilities managers and state employees, fantastic, with an interest in doing the right things, and just getting them to understand that we couldn't possibly write a technical spec that was ready to be plugged into any building project on concrete was like a good part of the conversation. People don't realize that every building is a unique thing,
Especially for concrete.
especially for concrete.
Yeah.
So anyway, so division 1.
So, and also step back, the way I describe Division 1 is that's where we set up the rules for how the game of construction works.
Mm-hmm.
The technical sections of the spec.
And then the language that actually goes into the technical sections is pretty brief. It's in part 2, you have your product and you say what your basis of design product is and what you want your embodied carbon to be. And then you have some performance requirements. Some people put it in part 1, some people put it in part 2, but your performance requirements will say what kind of EPD you want, what your top
That's
limit
great.
for the embodied carbon is, what your system boundary is, which is the whole like A1 to A3 stage, what your declared unit is, which may vary if depending on what products you've got, and what product category rules you have. And then you have submittals and it tells you what you need to collect.
It's just awesome.
It's pretty brief.
It's good and it's free.
So that sounds great, and it's prepped for release. It's all good.
Yep, it's all good. It's free.
Wonderful.
We can talk about it. It's obviously
We can
fine to
talk about it. It's out
for-
there.
Okay, perfect.
Yep. So the unit that we need to remember is kilograms per CO2 equivalent.
Okay.
That's
And it's
kg
interesting that we're-
C02E.
Yeah. See, this is interesting because that's one of the things that drives Jim DeLoisio nuts. He's a structural engineer colleague of ours that we've interviewed on this show. He was one of our first 3 interviews, maybe.
I think so.
And I present on carbon calculations with him all the time. And he's so frustrated because it's hard to take a metric like that and help architects and engineers in the United States understand them, because you've got the metric overlaid to an imperial process, and we're the one of 3 countries left in the world that don't use metric.
Yep.
But we're pretty damn big and powerful.
A lot of money gets spent here.
Yeah, that's another layer of confusion. And in fact, I was just reading, this has nothing to do with architecture, but I was just reading in the Bathroom Reader, which is the sum of all useless knowledge, that there was a story of an airplane that didn't make its destination because the calculation switch between metric and imperial didn't work between the British pilots and the American pilots and the crew for the plane. And so they were short on fuel and they barely got to their destination because the conversion was 3 layers deep and nobody did it right. And that happens a lot more often than we think.
Choose metric and abolish daylight savings time.
We should probably go to metric and also eliminate daylight savings time, but that's just another conversation.
I think that's another podcast for you.
Yeah, that's a whole other podcast.
Do one thing at a time.
So But the one more thing about the embodied carbon spec is that you can just do one thing. You could just pick one piece of your building and start there,
Yeah,
right?
that's a great point.
I mean, you can't do your whole building yet anyways, but you could do one thing. And so if you're doing a new building from the ground up, maybe you get your structural engineer really in deep on this and work on that. And if you're doing a corporate office fit out, maybe you just focus on carpet.
Yeah, that's fantastic. You're absolutely right. And then what happens when you do that is you're able to take the information from going through that process with one project.
Yes.
And then take that piece and say, this we get. Let's put that in the next one and do another product.
Right. And then
And so
eventually you
that's
get there.
That's awesome.
Yeah. And so my job is I get my different client firms to each do something different. And then I pull them all together.
Oh, masterful.
So like this firm's really good at this thing and that firm's going to do that. And yeah.
Oh, that's awesome.
Allow future innovations.
Is that enough excitement about embodied carbon for a few minutes?
Like,
I mean, I feel
never.
Like I know with Jody, you can't get enough.
So what are you using instead of cement?
Well, it's since it's a guidance spec, it mostly sets a maximum level for how much replacement that there can be with fly ash or slag or ground glass pozzolans or other approved pozzolans. It leaves it open.
Because there will be something else in the future.
There will be something else in the future. Yeah, see, that's also really interesting that we need to write at least the guidance materials in a way that we won't stifle innovation by mistake.
Right.
And that's part of the conversation.
And so that we can stop using fly ash.
Yeah,
which is
exactly.
A byproduct of the coal industry and full of toxic chemicals.
Yeah. And there's, I tend to fall on the side of the discussion that it's encapsulated in concrete. And if that concrete's buried, which it most often is, or for driving cars on, which is lead anyway, and all kinds of other toxins, it's not as big an issue. But others fall on the side of it should not be in there at all. And on top of all that, if we're eliminating coal burning power plants, we're not going to have fly
anymore. Yeah.
It's like Sweden burning trash as part of their movement towards zero net carbon for their country. Well, they're building an entire industry around burning trash, and the intent is to not ever do that. So we want to recycle, we want to reduce, we want to compost, we don't want to burn. And they've made it so that they kind of have to do that, have to have garbage. Yeah, that's crazy. Sorry.
We start digging up landfills and shipping it their way.
That's crazy.
Let's eliminate toxic materials.
Since the government started keeping statistics on children who get cancer, it was like 1973. And there's been a 35% increase in the number of children who've had cancer. Now, the survival rate is much, much better. Before the 70s, all children who got cancer died basically. And now they don't. But why do we have so many more cases of cancer? There's a very small amount that you can assign to better diagnosis, especially brain cancer. Apparently that was something I remember from this conference, that we have better brain imaging now than we used to. But for the most part, it's environmental exposure. And that brings us to things like PFAS in the water supply, PFAS in synthetic turf, infertility, all kinds of lovely stuff.
Phthalates to soften things that kids are going to be chewing on, which is something that drives me absolutely crazy.
Absolutely crazy.
Crumb rubber is a concern.
Let's stop using crumb rubber flooring inside buildings.
Okay, so unpack that a little.
Crumb rubber?
Why?
I'm an interior designer and I don't know what crumb rubber is.
Well, when you go to the gym and the floor is that black rubbery speckled stuff.
Synthetic rubber.
Oh yeah. Okay.
Yeah, so that's made out of recycled automobile tires.
Oh yeah.
And we have rules in this country that you can't recycle your automobile tires into more tires, which means it can only be downcycled. And so they grind it up. They clean it as best they can, but they grind it up and they mash it together and make more flooring products out of it. So
that's it, into flooring. Yeah.
think about what is on automobile tires: lead, arsenic, mercury, asbestos from brake pads, all kinds of disgusting stuff, all kinds of petroleum products. And you can't test the whole batch, right? You could test a handful, but how do you know that the whole thing is like that? So, and then we put it into floors and stick it inside gyms where small children lie on the floor.
Really? Roger Rabbit?
And
I always have a problem with that because of the smell more than anything. I get really bad headaches from that rubber smell. I don't know if it's synthetic rubber or natural rubber that has that smell, but
it's probably a lot of the toxins that go in with it.
yeah.
You know, like all those toxins that end in like xylene and toluene and all that stuff.
All the stuff that melted Roger Rabbit in the movie Roger Rabbit. That's what I always think of when I think of all of the like acetates and all the toluenes, all of that stuff was in that drum that the bad guy lowered all the
tunes
into the drum.
Yeah.
And we put that in our products.
You know, I was just
this is a real green chemistry problem, though. I mean, what else do you have for gym floors?
wood.
You know, fitness room floors. Yeah, but you're not going to put wood underneath your Olympic weight set.
Oh yeah.
Cork, and that's a renewable resource, and the cork will grow back into the trees, but it has to be managed different. It has to be shipped. It doesn't grow here in the same way.
It's also hard to get thicker cork.
Yeah, thicker cork.
And most cork on the market is full of some nasty resin that wouldn't pass the sniff test either.
Right, the resin on the surface, and also any glues that make it
Hold
thicker
it together.
Right.
Yeah.
Yeah, I actually I'm about to go in search of a product that doesn't have that. I'll keep people posted on if I find one.
Okay.
I have
one product made in the Netherlands, but I haven't gotten anyone to use it yet. I don't know why.
Oh, send it to me.
Okay, it's from a company called Herculan.
Okay.
And it's called they call the Blue Pad. There's a liquid linoleum product. You pour it in place, and
that's interesting. So wow, I haven't really heard of that.
Like you know about more interior products than I do, just by way of sourcing other people's specifications and being able to review what what is it? What are we putting in here?
Yeah. What is this stuff?
Yeah.
Go deeper and design for freedom.
And that's actually a new way to start talking to people about PVC. That, you know, PVC, yes, it's inert once it's in your building, but it's not inert to the poor people who live next door to the factory in Cancer Alley.
Right.
And, you know, that part of Louisiana that we refer to as Cancer Alley, because it's full of poor Black people with cancer, because U.S. petroleum companies built factories along there and didn't even hire the people who are getting cancer. They don't even work there.
Yeah. So have you seen Blue Vinyl? I mean, it's one of the first big environmental documentaries that hit probably close to 20 years ago, all about Cancer Alley and about research into dioxins and the issue with vinyl. And you would think, this is what makes me sad. You would think that after 20 some odd years of referring to a place as Cancer Alley, we would accept this as a real problem that could be solved. And yet
it could be solved. There's no will, and the petroleum companies just keep paying for the problem to go away.
Don't be fooled by the salt mill.
Well, I remember at one of the Greenbuild conferences, one of the vinyl manufacturers was handing out really cool little salt mills full of salt to make the point that
PVC is salt.
PVC is totally the same thing as table salt.
Yeah, no.
And therefore can't possibly be bad for you.
Ann Hicks Harney was just on a rant about that the other day too.
And it's time for us to wrap up.
This has been a lot of fun, and I could clearly talk to you guys for another couple hours.
I know, and I mean, we can. Tonight we can't do that, but we can have you come back.
Yeah, okay. Yeah. Let's chat again, whether it's to be recorded or not.
Thanks for joining us for Subject to Change.
All right, well, I'm gonna buzz out.
You're gonna jump. All right, sounds good. Thank you so much, Lisa.
Thank
Thank
you.
you
Thank
so
you,
much.
Lisa.
Always
You're
good to
amazing.
see you.
And I will talk to you both again soon, I hope.
Yeah.
Absolutely.